Hey guys, Mr. Baines here to talk about volume and density. This video is going to be broken into two parts because this is a long thing. So first things first, add this to your table of contents. Go ahead and pause it. We will be learning about objects sinking and floating based on their density, and we'll be able to find the volume of different objects. So find the volume of different objects. Find out whether they sink or float just based on their density, which is easy to measure, and draw molecules inside the objects with different densities. First, we're going to talk about volume. When we talked about matter, we talked about how in order for something to be matter, it has to take up space. Well, another word for that is volume. Any 3D object that takes up space is, or anything that takes up space has what we call volume. So a cube that has side lengths 1 centimeter times 1 centimeter by 1 centimeter takes up 1 cubic centimeter of space. And all you have to do is multiply the length times the width times the height. And that'll give you the volume. Okay, so this works for any cube or box. You can multiply the length times the width times the height. All right, please draw this example in your notebook. Go ahead and pause it. All right, when you do 1 times 1 times 1, you get 1. Okay, and that's 1 cubic centimeters because there's 3 centimeters, 3 dimensions. All right, make a tip chart for the word volume. Go ahead and pause it. All right, just to test whether you were listening, what is the volume of this rectangular prism, this box? Go ahead and pause it. The correct answer is C, 21 cubic centimeters. If you do 7 times 1, that's still 7. And then 7 times 3 is 21. 21 cubic centimeters because there's 3 dimensions, length, width, height. Measuring volume is actually pretty easy if the shapes are easy. So spheres, cubes, boxes, cylinders, cones, because all we need is math and we already have formulas. But what if I were to hand you an object like this? How would you find the side length of this? Where's one side even start? So how about this? Well, it turns out this is actually the problem that challenged this man, Archimedes. And we're going to learn about his story. We're going to learn about the first part of his story and then the second part next time. So here's the story. You may read along. The king of Archimedes' country, Greece, needed to know the volume of his crown. So he asked Archimedes if he could find the volume of the crown. That night, Archimedes went home and was getting into his bathtub. He noticed the water level go up. Then he jumped up and shouted, "Eureka!" And in Greek, this means I found it. He was so excited by his discovery that he didn't even get dressed as he ran outside, continuing to shout, "Eureka! Eureka!" So at least this is how the story goes. The king really needed to find the volume of his crown. Archimedes didn't know how, but he came up with the idea when he was getting into his bathtub, and he didn't even put his clothes on and ran outside and started shrieking, "I found it." And he's not a crazy person. He actually did find something very important. Hint, he did not find his rubber ducky. That's not what he found. But it does have to do with his bathtub and the water in it. What I want you to do now is I want you to think about it. How could he have measured the volume of his crown? It has to do with his bathtub. That's the hint I'm giving you. So pause this video and think about how he could have done it. When you write it down and then unpause the video so I can tell you what he found. Go ahead and pause it. Welcome back. I hope you came up with some good ideas about how to measure the volume of a weird object. So first I'm going to teach you a little bit about graduated cylinders and how we measure volume. So we put water into these little cylinders, and they're 3D cylinders, that have markings on the side. These markings mark off milliliters. Okay, so water's kind of weird, and actually most liquids are weird. When you put liquid in it, it kind of sticks to the sides there, so it makes a little, almost looks like a bubble, upside down bubble. You want to read from the bottom of the bubble. So yes, the water does go up to 20, but this is actually 19 milliliters because the bottom of the bubble is at 19. Okay, and this one, yes, the water does go up to 80, but you can see right here that the bottom of it goes to 79. So 79 milliliters is the correct measurement on this. And for this one, I want you to try it on your own. It looks like it goes up to 26, but the bottom of it is on 25. So write your answer in your notebook. Go ahead and pause it. The correct answer is 25 milliliters. It goes up to 26, but the bottom of it is on 25. What is the volume of the green rubbing alcohol in this graduated cylinder? Write your answer in your notebook. Go ahead and pause it. All right. The water looks like it goes up to 52, maybe right there. And maybe even 53. But the bottom of it goes to 51. But there are two answers with 51 in them. Is it 51 milliliters or 51 cubic centimeters? Well, actually, both are correct. These are the same thing. It's just a little easier to write ml than cm cubed. So milliliters and cubic centimeters are the same. So the correct answer is actually D. All right, so this is how we can find the volume of weird shaped objects, and this is what Archimedes found. If you put a rock inside of water, the water will go up because the rock is moving the water out of the way, or what we call displacing it. Okay, so when you put this rock in there, the water level is going to go up. It's going to go up exactly equal to the volume of the rock because it's going to move exactly this much water out of the way. So the volume of this rock is actually 11 milliliters, 11 milliliters, or 11 cubic centimeters, the difference between 41 and 30. So this isn't exactly what he did, but this is a pretty close idea of what he did. He put the crown in his bathtub, and he had these markings on the side, probably. And he put it in, and then the water level went up. Started at 30 and went up to 25. Now, actually, probably what he did is he filled his bathtub all the way full and then caught all the water that spills over the top. Okay, so all the water that spilled out of him. You can also do it this way if you have a big enough tub. All right, so what is the volume of this crown? I want you to figure it out. It starts at 30 milliliters and goes up to 55 milliliters. What is the volume of the crown? I'm going to go back a slide, but go ahead and pause it. The correct answer is A, 25 milliliters. It starts at 30 and goes up to 55. So the difference is 25 milliliters or 25 cubic centimeters. This is the end of part 1. Stay tuned for the rest of the story. I'll see you next time.